Okay class, we've been studying circles, and I want to make sure we know some definitions on those circles. So I first want to take a look at this diagram I have to my left. Here I have labeled the center of the circle as D, so we would call this circle, circle D. I also have a couple of vertices that are on the circle. B, C, and A are all on the circle. And so we're going to label a couple of things. The first thing I want to discuss is something called a minor arc. A minor arc is formed by having the vertices along the edge of a circle. This is the arc BC. Okay, and I'm actually going to write that out in terms of its arc first. So this is arc BC. We call that a minor arc because it is smaller than 180 degrees. Okay, we have a major arc. The major arc would go from B to A to C. That goes the other way, all the way around this. And that is greater than 180 degrees. So your minor arc is less than 180 degrees, and your major arc is greater than 180 degrees. Now these two arcs together make up the entire perimeter of the circle. So we have the entire perimeter from B to A to C and back to B again. Okay. We also have a few other things listed here that are important to us. The angle that's formed from B to D to C, angle BDC, we call that a central angle. It's called the central angle because it goes through the center of the circle. And one more angle, B to A to C, we call that one an inscribed angle. Inscribed angles means that each of the vertices are on the circle, and we call it an inscribed angle. So this is inscribed. Now there's some really neat relations amongst these angles and these arc measures, and I want to be very careful with the word measure. Measure does not mean length. When we're talking about measure of arc, the measure of an arc is related to its degree, not to its length. So we'll start first with that measure of BC, the minor arc. Now I'm going to give it a value for now, and we'll see how they're all related. So I'm going to say the measure of arc BC, this measure right here, will be 40 degrees. Okay. Now the measure, as I said, is the in degrees mark. It's what the angle would form had this central angle intercepted that arc BC. So the intercepting arc from BC, from the central angle BDC, has to have the same measure. So I know right now that BDC, the central angle, has the same measure of 40 degrees. Okay. Now the major arc, the one that goes from B to A to C, that would be the remaining piece of the 360 degrees. So if I knew that BC was 40, this remaining measure out here would have to be the remaining 320 degrees. Okay, and lastly, this angle that's formed from B to A to C, that is the inscribed angle. And you can see that the inscribed angle appears to be smaller than the central angle. In fact, this inscribed angle is exactly 1/2 of the measurement of the central angle. So if this is the 40-degree measure, this one would have to be 20 degrees. So the measure of BAC is equal to 20 degrees. And those are some of the relations we have amongst vertices on the edge of a circle.